This assignment is all about designing your code, designing your software, and uh, at least that's the theory behind it. So before you actually get to doing the design, that's where the assignment sort of leads off. Um, yeah, you need to justify and plan your actual project, and it helps if you know how to design your project because you feel better with your plan. Um, so, and this was broken down into 3 steps, just to recap where we are so far. So the first thing you have to do was your plan. Um, as part of your plan, you need to say why you chose to do this project. So what you need to do is put together at least two specifications of two different projects, which can be two different versions of the same project, or it can just be one new project, or it can just be two totally separate projects. Basically, you need to have two projects that you can choose between. So you have two different specifications, um, and then you do a cost-benefit analysis for these two different specifications, for these two different potential projects. Like I say, that can be two totally different projects, or it can be two different versions of the same project. But you need to then, having done two different specifications and two different cost-benefit analyses, you need to then justify why you chose this particular project. And if you can add other factors into your justification, that would be great. We looked at doing a risk assessment last week, and there's some details on that online. And you can go into a lot of detail about cost-benefit analysis. And yeah, there's an earlier presentation which goes through that. And then you have to do a presentation. You also have to develop a presentation to your client explaining what they can expect. So we've covered all this as well. I'm just doing a recap. So yeah, you need to explain why you chose this project, which will draw from the cost-benefit analysis, feasibility study, analysis, which you've probably already done. So just say why you chose to do this specific project. And yeah, a presentation to your client, which will include a project summary, some costs, some benefits, and maybe an overview of your plan, and possibly some ideas of the risks that might be involved, depending on the project. And yeah, and then, so this is what we've done, this is where we're up to. This is where we've recapped the last couple of lessons. Hopefully that will make sense. And if you've got the questions, you can bring them out, or hopefully we've already done all the questions and this all makes sense. And you're well on your way to finishing all this. Splendid. And then we do the design, which I did talk about briefly at the start, just so you knew what to expect, but I don't know how many of you have actually done all of this. Some of you have done use case diagrams already, which is great. Yeah, so use case diagrams are yeah, which can be useful. So we've done those already. It's where you have to. Have I got a slide on use case diagrams? But no. So I've got lots of separate resources on use case diagrams. Use case diagrams is where you figure out who your clients are, or who your users are, who's going to be using your system. You draw a stickman to represent each of the different user groups, and then you have like bubbles coming out of each stickman saying what they can do. Each bubble is going to feature that person to the next one. Yeah. Yeah, so use case diagrams are an extremely good place to start when you're going to design your software. Who's going to be using it, and what can they use it for? And that will help to start fleshing out the idea in your mind. The next thing that I would suggest you do is a structure diagram. So here's an example for a college app, or an app for the college, where you have, at the top, you have like the big problem, and then you break it down into a series of smaller problems. And each of these small problems would then be a module. Yeah? And you would then code each of these modules individually. Rather than just writing a long string of code, if you break up your big impossible problem into a series of smaller problems, and then code each of these problems and test each of these problems individually, then it makes it much easier to write your code. You'll see most of the books, most things talk about modules. Most of the people talk about how to create modules. Modules are also known as objects. In Java, every module you create is an object or a class of some kind. Objects and classes are similar but slightly different. Objects are usually a type of class, or class is the sort of type, and objects are the actual physical things. Another way of thinking of it is a class is like a blueprint for a module, and then your object is the actual module itself, or a block itself that you can use. And so yeah, so your class. I mean, before you can create an object, you first need to create a class. Yeah. So you have like a blueprint that you can then use to create things. So a class is, you give it a name, in this case computer, so this we're defining what a computer is, and then we say a computer will have a speed, it will have CPU speed, it will have an amount of RAM, and it will be running an operating system. And it will be able to boot, it will be able to shut down, it will be able to accept inputs and outputs, and it will be able to upgrade the memory. These are things that you can do to all computers. Yeah? So having defined your class, having defined your class, you can then start creating objects of that class. So having defined what a computer is, it's very easy to then create a computer called Blackbook O, which will have a CPU speed of 2 gigahertz, a RAM size of 4 gigabytes, and is running Windows 7, and then it can do all these things. And then I can create another object called OCD, which has a different speed, different details, but can still do the same thing. Thank you so far. So these bits down here, these are called methods, and this is where you'd actually write your code. This is where you'd actually write your series of instructions. Most of the time when you're writing things, this is what you're writing. You're writing methods, you're writing a procedure, you're writing a series of steps of things you want the computer to do. These are called attributes, also known as variables. This is where you'd be temporarily storing your data. So these can change. So if you want to upgrade your RAM, then you write Blackbook O dot upgrade RAM, and then you put a number in the brackets, and that will then change this number here. You can't access these values here directly. You have to go through these objects. You have to go through the methods of the object. You have to go through the procedures of the object. You can't directly access the RAM. Otherwise, it might get a bit weird. So I don't know. If you could access this directly from a different object, then it might mean that you start upgrading the RAM in your computer, and then when you finish, the RAM on mine goes up and the RAM on yours stays the same or something. It's called encapsulation. It's a sensible thing to do. In order to access these variables, you have to use these methods. So just to put into context some of what you've been doing already. So yeah, classes and objects. Bizarre thing about code, it's difficult to know where to start explaining coding, which angle you're coming at it from. All of you have done some coding already. So hopefully, if I say variable or instructions, you can sort of visualize some of what that means. Good. So any questions about this? Any comments? I mean, again, we have gone through a bit of this already, but now would be a good time to ask questions if you have any. You don't have to explain what a class is and what an object is, but you will have to make some object diagrams. So you will have to understand what they are in order to create some of the diagrams that I'm going to show you in a minute. So the structure diagram, you don't need to know anything about, you need to be able to understand projects in detail, but you don't necessarily need to be able to talk about anything specific. You don't need to be able to talk about any coding details. It's just big problem and then series of smaller problems. Whereas in the other diagrams, in the communication diagrams, it's very useful to know what an object is in order to create this diagram. If you don't know what an object is, it's kind of hard, really. Yes. There can be. That's what, okay, so use case diagrams, yes, 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 exactly, exactly. Okay. Um, okay. Um, use case diagrams and communication diagrams are both types of UML diagrams. They both come as part of UML stands for Unified Modeling Language. It's a suite of diagrams that you can use. There's at least 6, and there may well be more. Structure diagrams sort of predate those. The main reason why I'm choosing to do use case diagrams, structure diagrams, communication diagrams is because that's what's listed on the list of things you need to know about on the HSE specification. They are also very useful to learn how to do. Use case diagrams and communication diagrams, there are sort of other steps in between these. And it sounds like it might be worth my while. In order to answer your question properly, I would need to then talk about... Okay. Yes. Okay. I think that's a good idea, actually. I might do a worked example of this process in a minute. Yes, that should be relatively simple. We won't necessarily flesh out the entire game in Pellet, but we can at least do enough to see how it all fits together. That's a good idea. Okay, let me finish this, and then I'll put something together doing a worked example. I suppose because I'm giving different examples. I gave an example of the use case diagram in a different presentation. I've got a structure diagram here, and then I've got some objects which don't relate to the structure diagram. Yeah, it's a good idea. I'll create an example. It's a good idea, actually. I will do exactly that. This is inheritance. Okay, I'll finish this, and then I'll do a worked example. We have a class of computer. So this is our class computer, and this is our computer objects. Now, when you create objects, it's very rare that you will create an entirely new object. Usually, what you do is you create an object that inherits from another object. So when you create an object, you're saying, so if you wanted to create an object of, say, a smartphone, you wouldn't write the whole thing from scratch. What you would do is you would subclass computer. So if you want to create a smartphone, a class smartphone, which has a CPU, speed, and amount of RAM and an operating system, and can do all these things. But a smartphone also has a battery, so it'll have a mounted charge of the battery. It'll have a camera, and it will be able to charge your battery, and you'll be able to take pictures of it. So a smartphone is still a computer. It's just a type of computer. Similarly, if you want to create another object called desktop, then this would inherit from this. So a desktop also has a CPU speed, RAM size, and OS type. It will also have a graphics card, and it will probably also have a hard disk. Two things you won't find in a phone. So these are two different types of computers. All smartphones are computers, all desktops are computers. But smartphones and desktops are not the same thing. Yeah? This is called inheritance. And this type of diagram is known as an object diagram, which is another type of diagram you can draw if you like. This is another type of UML diagram. And this is the process of inheritance. So smartphone inherits from computer, and this is the full definition, which is what I just said. So if you see words like inherits and derives, then and subclassing, then that's what's going on here. You may well come across these words. That's what they mean. And this is how you would use them. So you may well see and be writing code that looks a bit like this. So if you want to increase the battery level on a phone on this particular object, then you type the name of the object and then put a dot and then type the name of the the method that you want to use. So if you want to increase that number there, then you would type 07.charge battery. And then that will give you instructions that will give you instructions for increasing the battery level. Similarly, if you want to switch it off, you type 07.shutdown, and then it will shut it down. Yeah. So you will find yourself creating classes, and then once you've written your classes, you will create objects so that you can then use these methods directly. And I will give an example of this in a minute to show how to progress. And yeah, this is encapsulation, like I say, you can only access via these methods. So if you want to switch my phone off, press the power button on my phone rather than press the button on my phone and switching off your laptop. They have to, if you want to access these, you have to go through these. And that's what this word encapsulation is. That's why some things might not seem very logical. Why can't I access it directly? You usually have to go through these methods. So I hope all that makes sense, because this is a communication diagram. You have to draw one of these. And in order to be able to draw one of these, you need to understand what all of these classes are. So we have a class of student, we have a class menu, we have a class called object course advisor. This is a class and this is a class. And these yellow bits are methods within each of those classes. So if student wants to send some details to course advisor, or if the course advisor needs some details from student, course advisor, you'll have a line of code in here, some in your course advisor block, in your course advisor class, that will call, you'll type student.details, and that's how you can get the information out of these different blocks, out of these different classes, how your blocks of code communicate. That is a very high-speed overview of what an object is and how they work together. And like I said, I'll give you a worked example in a moment. Hopefully that makes sense. It's not. So I do a worked example, and you can ask me more questions. Does that make more sense? So I don't think there's nothing particularly difficult in there. It just might seem a little bit odd to start with. And then when you start using it, it makes more sense. Yes. I'm sort of looping around with my example. We've got one example using some phones, and then we've got another example for mobile phones. So the two ends of the same puzzle. Okay, so taking a step back, the communication diagram, I think, is the only one that you're likely to struggle with. I would guess that the use case and the structure diagrams are going to be relatively simple and straightforward. The structure diagram doesn't have to necessarily relate to the communication diagram, though it's nice to say that. I mean, the diagrams don't necessarily have to relate to each other. In order to pass, or do well, you just need to tick a box that says you have created a structure diagram and you've created a communication diagram. But obviously, it's more useful for us to know what they are and how they work, instead of designing and creating your own code. So, can I suggest that you work on either use case diagrams or begin a structure diagram if you haven't done so already? And I'll put together an example.